Welcome to notes 12.3 and 5, day 1. All right, so these notes are about cylinders. In our previous lesson, we talked about prisms and we memorized some formulas. So for a prism, the formula for lateral area was perimeter times the height. For a cylinder, that's exactly the same. The formula is still perimeter times the height, only in this case, our perimeter is known as our circumference times the height, which means that since circumference is 2 pi r, then we have 2 pi rh or pi dh. So you don't really have to memorize another formula, you just need to know how the formula translates. Okay, same thing for surface area. We take, in our prism, we took our perimeter times our height and we added the area of the two bases. Same thing here for a cylinder. So we will take our perimeter, let's use 2 pi rh, times our height, and we will add 2 times the area of the bases. Well, the bases are circles in a cylinder, so it's 2 pi r squared. Okay. The interesting thing about this particular form of this formula is that you can factor out what they have in common, which is a 2 pi r, and that leaves you with an h and an r. So sometimes you'll see it in factored form. But again, it's the exact same formula as for the prism, just modified to take into account the fact that the bases are now circles. All right, volume, same thing. Volume for a prism was big BH, so we are talking about pi r squared, which is our big B for a cylinder, times our height. And that's all there is to it. All right, let's do some practice problems. So in these problems here, if we want to find our lateral area, our surface area, and our volume, then we need to write down our formulas, just like we did with our prisms. So this is 2 pi rh. This is 2 pi rh plus 2 pi r squared. And this is pi r squared h. So there's even fewer things that we need to know. So actually, cylinders are easier than prisms because all you need to know is you need to know what r is and you need to know what h is. And then you know everything from your formula. In this case, r is 3, h is 8. 8 is still the distance between the bases. So we just fill everything in. So this would be 2 times pi times 3 times 8. And unless you're told otherwise, you are going to leave pi in your answer. So our answer here would be 2 times 3 is 6, times 8 is 48, so 48 pi, and its area, so it is meters squared. So we take that 48 pi, and we add 2 times pi r squared, so 3 squared. So 3 squared is 9, times 2 is 18. So I had 18 plus 48 with that 58, 66. So 66 pi meters squared. And then finally we have pi 3 squared times our height, which is 8. So I get 9 times 8, which is 72 pi meters cubed. Very straightforward. All right, I would like you to do the same thing for number 2 and come back and check your answers. Hit pause now. And you should have gotten a lateral area of 90 pi meters squared, a surface area of 252 pi meters squared, and a volume of 405 pi meters cubed. Moving on. All right, in this example, we're actually given the surface area and we have to find the height. So our formula that relates surface area to height is the surface area equals 2 pi rh plus 2 pi r squared. So 198.8 equals 2 times pi times my radius 2.8 times my height plus 2 times pi times my 2.8 squared. Now, since our answer does not have pi in it, we're going to go ahead and we're going to use the pi button for pi, obviously, on our calculator, and we're going to solve for h. So we can actually do it all in one step. We're going to subtract this. So what I'm going to type into my calculator is 198.8 minus 2 pi 2.8 squared, and then we are going to divide by the number in front of the h, so divided by 2 pi 2.8. So I'm going to pull out my calculator, and that will give me h. So when I type that all in, I find out that h is about 8.5 millimeters. Okay, question number 4, very straightforward. So I am going to ask you to find all of those for me in the notes check. Question number 5, if the volume of a cylinder is 18 pi meters and the height is 2 meters, what is the total surface area? All right, what we really need to do is use this volume to find the radius, and then we can go forward and find the total surface area, because we can't go straight from volume to surface area. So my formula for volume is big BH. In this case, that is pi r squared h. So I've got 18 pi for my volume equals pi r squared times my height, which is 2. All right, I divide both sides by 2 pi, and I find out that r squared equals 9, which means that r equals 3. Now I can take my radius and my height, and I can plug it into the formula for total surface area. So surface area equals 2 pi rh plus 2 pi r squared. So this is another case of the more you write the formula, the easier it is to memorize. All right, my surface area equals 2 times pi times my radius of 3 times my height of 2 plus 2 times pi times my radius squared. And I get, let me see, 12 pi plus 18 pi. So my total surface area is 30 pi meters squared. Final answer. All right, good job. Now let's change pace a little bit and let's talk about similar figures. So we've talked about similar figures before as it related to polygons. And we found out that the relationship between the scale factor, so if my scale factor was A to B, then my perimeter ratio was also A to B. And then we took that one step further and we found out that if the perimeter ratio and the scale factor were A to B, then the area ratio was simply that squared, A squared to B squared, which makes sense because area is measured in squared units. Well, volume is measured in cubed units, so it also makes perfect sense that the scale factor of my volume would be A cubed to B cubed. Pretty straightforward. But first we need to know if figures are actually similar. And if they're similar, then all of their corresponding parts are going to be proportional. So for example, in these two cones here, if I take a ratio of their heights, and then I reduce it, so this reduces to 2/5, and then I take a ratio of their radiuses, that reduces to 3/5. Well, these two ratios, the reduced form of the ratios, are not equal. Therefore, these are not similar. All right, over here, if I check the ratio of the heights of these two cylinders, so 7.5 to 15, that reduces to 1 to 2. And then if I take a ratio of their radiuses, radii, I get 2.5 to 5, which also reduces to 1 to 2. So their corresponding parts are proportional, so these guys are similar. Okay, so here we're told we have two similar cylinders, and furthermore, we know that the scale factor is 2 to 5. And we need to find the surface area and volume of the larger one given the surface area and volume of the smaller one. So we're going to need to set up a couple of proportions. Our first one will deal with surface area. And we know if we're talking area, then we take our scale factor and we square it to compare areas. So the area of the smaller one is 96 pi, and we are looking for the area of the bigger one. So we're looking for the area of B. All right, so we're going to simply square our scale factor, and then we are going to cross multiply and solve. So cross multiply, I get 4 times the area of B equals 25 times 96 pi. So I divide both sides by 4, and those cancel, which means that, I'm running out of space here, the area of B is 600 pi, and the units are feet squared. All right, let's look for volume. So with volume, I take my scale factor and I cube it in order to be able to compare two volumes. So my volume of the smaller one is 128 pi, and I'm looking for the volume of B. So again, this time I cube, so I get 8 over 125 equals 128 pi over the volume of B. And we cross multiply and solve. So 8 equals 125 times 128 pi, divide by 8, and I get that my volume of B is equal to 2,000 pi, and the units are feet cubed. That's straightforward. My two final answers, this one and this one. Okay, here's a similar problem. This time we're talking about cones, but that doesn't change anything because we still know the scale factor, and we know the surface area, and we know the volume of cone A, and we're looking for the surface area and volume of cone B. So I would like you to solve this the exact same way I just solved the previous one and give me the answer in the notes check. Be sure to follow the directions on rounding. All right, word problem. We've got a store. It sells birdseed in two sizes of cube-shaped blocks. The smaller block measures 3 inches on an edge and sells for $1.99. The larger block is 5 inches on an edge and sells for $5.99. And we need to figure out which block is the better buy, and we need to justify our answer. Well, we can justify with the math as long as we can figure out what the math should be. So the first is, what type of problem is this? Well, when we sell stuff in cubes or packages or any kind of prism, we're talking about a volume problem. Okay, because we're talking about the price per ounce. Any kind of weight is a measure of volume. In this case, we're going to be talking about the price per cubic inch, right, since inches are the units that we are given. So what we need to do is we need to find the volume of each of these blocks, and then we need to figure out the price per unit. So they're cubes, which means that to find the volume, I am just going to cube my side edge. So for, let's call them small and large. The volume of the small one is going to be 3 cubed, which means that the volume of the small one is 27 inches cubed. And the volume of the large one is going to be 5 cubed, which means the volume of the large one is going to be 125 cubic inches. Now, when you're at the grocery store and you're trying to figure out what's the better buy, sometimes some grocery stores have that little sticker on the shelf that says the unit price. Well, the unit price is the price per each unit. So the way they do that is they take the amount, so in the case of the small one, that amount is $1.99, and they divide it by the units. And that gives you the cost per cubic inch. So same thing over here, we would take the $5.99 and we would divide it by the units. And whichever one of these comes to the smaller number is the cheapest price per cubic inch. So let's bust out our calculators and let's see what we get. Okay, so for my small one, I got 7 cents per cubic inch, and my large one was 5 cents per cubic inch, which means that my large one right here is the better deal. Better deal, lower price. That's my justification. And you would think that would always be the case, but it's not necessarily always the case. So be a smart shopper and go ahead and check that unit price to see, because sometimes they mess with you to check and see if you're paying attention. So this concludes today's notes. Please go on and do the notes check. And if you have any questions, be sure you ask in class. Thanks.